In this lecture, let's talk about some very basic and important things. Let's begin by talking about displacement, and distance. Now, let's say you start from your home and you're sort of going on a stroll and you travel like this. So one can ask how much you travel, and if you measure this distance or if you measure this length, this is called the distance you have traveled. So this is actually the length traveled. But one can actually ask, how far are you from your home from your home at the final position, which means from your final position, how far are you from your home? And then you are not going to tell this whole distance. Instead, you have to tell this distance. In fact, you can also tell in which direction are you from your home at the final position, and this particular thing is called a displacement. So displacement is the resultant of the motion, and if you recall from the last class, distance should be what? It should be a scalar. It's a scalar because it's just a number. Well, displacement should be a vector because this is actually the resultant of your motion. So vector displacement is a vector which tells you not only about the direction but as well as magnitude of the motion. So this is very important. Now let's talk about a few basic definitions. Speed. Speed is defined as distance, or actually change in distance divided by change in time, while your velocity is defined as change in displacement divided by change in time. So let's say you started at 0 seconds and you ended your journey in, say, let's say 1000 seconds, and all the while you traveled, let's say, 1000 meters. So what is the speed? Sometimes it's also called the average speed. You can also call this average speed. So what is the average speed? Well, the average speed is going to be thousand divided by 1000, which is equal to 1 meters per second. And let's say this distance is 20 meters, right? Then what is going to be the average velocity? Well, the average velocity will be 20 divided by 1000, which is going to be how much? 0.02 meters per second. But there's a small difference because displacement is a vector, average velocity is also a vector. So in principle you should write this average velocity as 0.02 comma theta. What is theta here? Well, to understand theta, we have to refer to the last class. Theta is defined as the angle this displacement makes with the x-axis, and that's how we have defined our x-axis, and this is our y-axis, right? So this is how we define average velocity. Now we know that we understand what is displacement and what is distance. We also understand the speed and velocity. So if you're going at 60 miles per hour in your car, your average speed is 60 miles per hour. Or let's say if you're going in a straight line like this, a straight line at 60 miles per hour, let's say towards east, then your average speed is 60 miles per hour. Sorry, this should be mi, miles per hour, and your average velocity will be 60, 0, assuming this is you're traveling in the east direction. So you're traveling in the east direction, which is along the x-axis, and so the angle theta is 0. So average velocity is this. Now I hope you understood this. Now what you decide at somewhere here, you press your gas pedal, and what happens, your speed starts increasing. So what is happening? Once the speed starts increasing, then we say that the system is in acceleration. So let's take an example. Let's say somewhere here you were 60 miles per hour, and then along a time change of 1 or 0.1 hour, you went from 60 to 80 miles per hour. I have seen speed limits of 80 miles per hour, so that's legal. So what is the average, or what is the change in speed here, or the velocity? Well, in this case both speed and velocity are the same because you're traveling in just one direction. So what is the average? You see, in this particular case, average speed and acceleration were not same. Average speed and average velocity were not same. But in this case, because you are traveling in a straight line, average speed and average velocity are the same. Okay, let's see how much was the change in velocity or speed. This was 20 miles per hour. And how much was the change in time? It was 0.1 hour. Well, this quantity delta V over delta T tells you how fast you changed your speed. So if delta V was large value, that means your rate of change of speed was higher, and if you did this in a smaller time, again your rate of change was higher. So this is 20 divided by 0.1, which is 200 miles per hour square. Pay attention to the units. What is this thing called? This thing is called acceleration. Tells you how fast you accelerated. If this is a larger number, that means you were pressing your gas pedal real hard, so that delta V was really high, or delta V was really small. Anything can happen. Either delta V will be higher or delta T will be smaller to get a higher value of acceleration. So this is a summary of these three basic things which are we going to talk about in the next class.